this will just be a short lecture about sets and intervals and some notations for that before we get into the real core of the mathematics. We have already talked about sets and intervals in different contexts. When we come across, for example, in Venn diagrams and intervals, we talk a lot about when we had functions and so on. But let's just say something here in a separate video before we continue. So a set is just a collection of objects. So just a collection of objects. It could be, for example, numbered balls, 1, 2, 3, 4, or colored balls for that matter, or some colored objects of some types. Could be letters, could be anything basically. Normally in mathematics you talk much about numbers, sets of numbers. And then you can of course talk about the set of integers, or the natural numbers, that 0, 1, 2, and so on. And often when we talk about set, you put them into parentheses to show that this is a set, this type of parentheses. Okay, but generally you can have it like a collection of anything. So let's say you have a collection of colored balls. So that could be a set. Okay, so this is just a set of balls. So a set is just a collection of something, collection of objects, whatever type of objects. And for example, when we talked about probabilities, we had Venn diagrams, and then we talked about sets A and B, and then we talked about unions and intersections, for example. This is also a part of what we call sets. We're talking about sets. So these types of things we will come across sometimes. We won't cover it all here thoroughly, but just to mention what it is. An important special case of a set is for us interval. So what is an interval? If you just have let's say you have a number line here, and you put 0, 1, or whatever, 2. Then interval is just a continuous set of numbers. I didn't get the color I wanted here. So let's say this, from the numbers here to here, is a continuous set of numbers. So if I start, for example, at 0 and go to 2, and let's say I want now that 0 should not be included, then I can write a circle, not fill in. But I want 2 to be included, I can write the circle, fill in. So this is all the numbers from 0 until and with 2. And that could write in symbolically like this. So it's from 0 to 2. And then I put this kind of parenthesis. This means that endpoint 2 is included. This means that the endpoint is not included. So if both endpoints would have been included, I can write it like this. And if, for example, if the starting point but not the endpoint should be included, then we have like this. And for example, if I have a set like going from 2 to infinity, then I cannot include this, so then I have to put it like this. Then I can choose 0 if I want to include a starting point or not. So these are notations for intervals. You can also, instead of writing it like this, you can also write it like this. All the x, if you call the x here, between 0 and 2, you can write it like this with an inequality signs. So x larger than 0 but smaller than equal to 2. So this means the same here. This is just another way of writing this interval. And also we will sometimes earlier we have used notations like this, for example, that 3 plus minus 0.1. When we were talking about measurements, for example, we talked about this in the sense of intervals. So this meant not two numbers, 3.1 and 2.9, but it meant all numbers from 2.9 to 3.1. So this is quite common to use, for example, in measurements or statistics. All of these just different ways of expressing intervals.